In this video, we'll take a look at z-scores, or finding the location of a score in a distribution. Now, z-scores are given by the following formula, where we have z equals x minus mu divided by sigma, or the standard deviation. And here x is a raw score, or a value on some variable x. Mu is just the population mean, and sigma is the population standard deviation. And notice here that in this z-score formula, both central tendency and variability are used to obtain a z-score. Now, z-scores indicate the number of standard deviations a score is away from the mean, and we'll be exploring that more in just a few moments. Z-scores can be positive, or above the mean. They can be negative, which is below the mean, or they can be 0, which is equal to the mean. Here are a few examples where we have a z of positive 1, a z of negative 2, and a z of 0. So a z of positive 1 indicates that the score, or x, is one standard deviation above the mean. Now, it's above the mean because it's positive, and it's one standard deviation above because z is equal to 1. A z of negative 2 indicates that a score is two standard deviations below the mean, and it's below the mean because it's negative. Finally, a z of 0 indicates that a score is 0 standard deviations away from the mean, and if it's 0 standard deviations away from the mean, that just means that it's equal to the mean. So if you ever see a z of 0, that value, that x, is just equal to the mean. Now, in this example, we see integers, but it should be noted that you also can have non-integer z-scores, such as a z of negative 0.5. Next, let's take a look at some examples for solving for z. And here's our formula once again in the upper right-hand corner of your screen. And in this example, we have an x of 110, a mean of 100, and a standard deviation of 10. So x is going to be 110, mean is 100, and standard deviation is 10. So as that's plugged into the formula here, we see 110 minus 100 over 10, or 10 over 10 is positive 1. And the way we interpret that once again is a score of 110 is one standard deviation above the mean of 100. We know it's above the mean because it's positive. It's one standard deviation above because z is equal to 1. And it's above the mean of 100 because we saw in this problem that the mean was equal to 100. Let's go ahead and take a look at another example. Here we have an x of 100, a mean of 100, and a standard deviation of 10. So plugging these values into our z-score formula, we see 100, that's the x, minus 100, which is the mean, divided by 10, or 0 over 10 equals a z of 0. And as we saw before, a z of 0 means that the score is 0 standard deviations away from the mean, or it's equal to the mean. Now here's an example where the value is less than the mean. Notice here we have x of 90, mu of 100, and standard deviation of 10. So plugging these into our z-score formula once again, we would get z equals 90 minus 100 over 10, or negative 10 over 10, or a z of negative 1. And this would be interpreted as follows. A score of 90 is one standard deviation below the mean. And once again, it's below the mean because it's negative. Here we have an example of x is 120, mu is 100, and standard deviation is 10. 120 minus 100 over 10 is 20 over 10, or a z of positive 2. So that means that the score of 120 is two standard deviations above the mean. So for our last example here, we have an x of 95, mean of 100, standard deviation of 10 once again. So 95 minus 100 over 10, or negative 5 over 10, is a z of negative 0.5. So we would interpret this as follows. A score of 95 is 1/2, or 0.5, standard deviations below the mean. Or it's 1/2 of a standard deviation below the mean. Now here are some practice problems where I have 7 problems with various means and standard deviations. And I encourage you to go through and try and solve all of these. On the next slide, the answers are provided. So you may want to pause the video, solve these, and then check the answers, which I'm going to move to now. So as I said, here are the answers for the problems on the previous slide. Okay, that's about it for z-scores. Thanks for watching.